Greetings, I'm Chini, a struggling indie game developer. Today, I'd like to talk about a very specific detail in my later game jam title, Tiny Spaceships from Outer Space. Basically, I'd like to show how a little bit of linear algebra knowledge can come in handy when programming gameplay. First, let me describe how my little game works. Spaceships spawn from above the screen, move from random position to random position within a specified region, before firing 3 shots at 45 degrees apart. One of the ships, however, does not pick its position randomly. Instead, it would move to a position that will allow it to shoot at the player from the side. I've designed it this way to keep the player constantly moving in order to survive. Now the challenge is, how do we find such a position? Let us better visualize the problem. Let's define the target position A as the center of the player sprite. This position is a 2-dimensional point. That means it's essentially 2 numbers, namely the x and the y component. Then, we trace the intended path of the bullet backwards from this point at a 45-degree angle. Truth is, there are 2 possible angles, 45 degrees and 135 degrees, depending on whether we want the spaceship to be positioned to the right or to the left of the player. To keep this demonstration simple, we'll stick to just 45 degrees. Here's the definition of the line, right here, presented as a parametric equation. As mentioned previously, the point A represents our target position. The vector u, on the other hand, represents the directional vector that helps to define this line. U's definition is as presented here. This is one way to define our directional vector in GameMaker, but we can also just call the trigonometric functions ourselves, like so. Here, a quarter pi radian is exactly 45 degrees. Since the cosine and the sine functions take in an input in radians, we have to do the necessary conversion from degrees to radians ourselves. Now, back to the parametric equation. The t in this equation here represents any arbitrary value corresponding to a point on this infinite line we have here. Okay, now suppose we want the ship to move somewhere along this green line, right? Y equals to 35, right? That's where we want the ship to be at. In order to pinpoint the exact position for the ship, right, where it needs to be, we need to calculate the intersection between the white line and the green line. So let's do the math for it. Okay, so we have here the 2 equations, right? So this is the diagonal line. This here, this is the diagonal line. This is the horizontal line, representing the y position of the spaceship, right? So this y here is given. Is it a given value? By that, I meant to say that the user, right, the coder, I suppose, will be providing the value. So this is given, right? This is the position, the y position of the ship. Right? This is given. Right, this is the player position, and then this is given. Alright, this is the, well, you know, this is the vector, the path of the bullet, right? Or the negated path of the bullet, to be more exact. Now, what we want is to find the t, right? Where these two lines intersect, right? Where this slanted line and the horizontal line intersect, we want to find the t at this intersection, right? What is the value of t when the point is right here? Like, once we found the t, we can calculate what the x value is. So let's work on solving this. There we go. We now have the formula for finding the ship's x position. Coding it in GameMaker would then look something like this. And that's it. That's how the spaceship knows where to position itself to shoot at the player at an angle. I hope this has been an interesting showcase. If you would like to see more of my work, please like this video and subscribe to my channel. You can also follow me on Twitter @Chiniken. Cheers, and I'll see you in the next one.